This is section 3.1, and today we're going to start a chapter about exponentials and logs. And the first part of this chapter is talking about exponents, and today we're going to start actually looking at some of their graphs. So far we've mainly covered algebraic functions, polynomials, radicals, that kind of thing. And now we're going to start these two types of non-algebraic functions called exponential and logarithmic functions. And the exponential function f, so just like f of x like normal with a base a, is denoted by f of x equals a to the x. So this is an exponential function. Now the variable is the thing in the exponent. Usually we're talking about like x squared, and now we're going to be talking about something like 2 to the x. So our variable is going to be up in the exponent. So just to give an example, we'll graph a couple of these so we can see what they look like. The first one we're going to graph is 10 to the x, and then we're going to graph 4 to the x right next to each other, so we can kind of see what the difference is. And you can use your graph or your calculator to do this, or you can make some XY charts. I'm just going to make a couple of little XY charts here. Where can I stick these? How about right here? So first, to do 10 to the x, an easy one is 10 to the 0. That will be a 1. Anything to the 0 power is a 1. And then 10 to the first will be 10. So to graph that, first I'll have 0, 1 right there. And then I'll have 1, 10, which would be right about there. So this graph will look like this. Exponential means it has to grow exponentially quickly. And this equation is going to be my 10 to the x. My 4 to the x graph, just kind of continuing on here, if I picked a 0, I'll also get a 1. And then if I put a 1 in there, I'll get a 4. So I'll still go through that point, and then at 1, 4, I'll go through there. So function looks almost the same, just a little more upright. And that was really bad because my pen stayed right in that spot. Sorry about that. And this one is y equals 4 to the x. So each of these exponential graphs is kind of easy to graph if you remember what an exponent looks like. So that's going to rise or grow exponentially quickly. And always pick 0 and 1. Those are the easy ones to kind of start off with. The domain for these functions is going to be all reals. There's nothing you can't plug in, but the stuff that you're going to get out is going to be your positive numbers, or anything greater than 0. We're not going to get any negatives coming out of this graph when it just sits like it is, a normal exponential. Now, if we start to flip it and do those types of things we were doing last chapter, of course, you can get it to come out to be negative. Y-intercepts, this guy's going to be 0, and this is where you let x be 0. And if that happens, then you're always going to have an intercept at 1. And again, that's before we start moving it or flipping it. Horizontal asymptote is going to happen right at 0. Or the x-axis right there. Okay, so now using kind of what we did last chapter, you can move all of these graphs, which is kind of what I was alluding to just a minute ago. You can start to add and subtract and put all different kinds of numbers in there, and it affects the graph just like it did last chapter. So if here's our normal graph, our regular exponential 4 to the x, which we just graphed right above. As soon as I put a plus 2 on it and it's up there with the x, then that means that it's going to move actually the opposite of that. So this is going to be a left 2 graph. So I'm going to take this and go left 2 and left 2. So this graph right here, this was my original. This was my g of x. This is now my h of x. My f of x, it says that it's going to add 2, so that means left 2. And then this minus 3 means down 3. So I'm going to take my original graph, my parent function almost. I'm going to move left 2 and I'm going to go down 3. So 1, 2, 3. This guy's going to go left 2 and down 3. And then this one will kind of look like this. And I'll put f of x down here. Oops, arrow. The last one that we're going to do is what would happen if I put a negative on it. And this one I'm going to graph and show you so that you know kind of how to enter this. So we're going to go 4 to the, and if your calculator, if you have an 84, it's going to put it up in the exponent, so you're kind of safe that way. If you have an 83, I highly suggest that you throw a parenthesis in there and then do a negative x. And make sure you're using the negative button, not the subtraction button. Those are two different things, and your calculator won't like it. Remember to hit zoom 6 so that it does a standard window, and then you're going to see that that flipped it right over the y-axis. So instead of normally increasing this direction, it flipped right over and is going to go down in that direction. So even though my graph's going to be really super messy, it's still going to cross there, and this point it's going to cross there, and that's what it's going to look like. So it just flipped right over the y-axis. So k of x is that one. So kind of a messy graph, but just getting the feel for what all these guys would do. And this was a flip over the y-axis. Just so you can see how they change and what you can do. And that actually, any of these numbers, the way that we were doing this last chapter, you can do the same thing with an exponent. It'll still move in the same manner. The other thing that always gets taught with exponential functions is about money, which everybody gets interested in. This is called the compound interest formula. And there's lots of variables in here, so we got to figure out what all of these things mean. A is the amount. It's kind of like the answer. Amount after t years. So how much money we're going to have. P is how much you start with, the initial amount. Sometimes it's called the principal. Like this is the amount that you start with. Sorry, brain farting. R is the rate. This is the interest rate that you're going to use. This is literally the number one mistake for kids, is to remember that when you are entering a percent, you have to change that to a decimal. So 3% would be 0.03 as a decimal, and that's usually what screws kids up, is they'll put a 0.3. I know I didn't like this because there's not a C in there. There we go. And then N, there's 2 of those, and this is the number of times per year you are compounding the interest. So just to give you some examples, monthly, you would say how many times does that happen a year? That's 12. Quarterly is another popular one. There are 4 quarters in a year. You could have daily, 365. You could have annually, which would just be 1 time. So all of those are different types. The last thing is T, which is time. How many years are going to go by? How long are we going to leave the money in the account to see how much we'll have? Okay. Next page, just doing a couple of examples with the money. So if you have $5,000 to invest and you're going to get 6% interest for 10 years, that should be an S. Find the amount in the account if you compound annually. So the amount is going to be the principal, which is $5,000. That's how much we're starting with. 1 plus, our rate is 0.06. We are supposed to get the interest annually. That means 1 time a year. And then in the exponent, you're going to have a 1 times how many years you're going to leave the money in there, 10. Now, most kids can set that up. Plugging it into your calculator usually is an entirely different process. So let's try plugging this one in. So we're going to do 5,000, parenthesis. You can do 1 plus, parenthesis, 0.06 divided by 1. And I know it seems kind of silly because we're dividing by 1, but as we move into quarterly or daily, it kind of helps to get in the motion of how these parentheses are going to go. And then you need to do to the, because we're adding an exponent. If your calculator does this, if you have an 84 and it throws it up there, then you're probably good. If you're not, if you have an 83 and it put the caret in there, that little arrow caret, I would definitely put a parenthesis to protect your exponent. And I would do 1 times 10. So the amount of money we're going to have is $8,954.24. Not bad for annually. $5,000 at 6% interest. That's making me almost $4,000 over that period of time. Now let's try it quarterly. So now I've got my amount. Principal stays the same. 1 plus. My rate stays the same. But this time quarterly means I'm going to get the interest 4 times a year. And then up here I'm going to have a 4 times 10. So all I have to do is change that 2 places. I got to change the 1 to a 4. And I need to change this 1 to a 4. Let me tilt that a little bit. So the 2 places you're changing are where that N was. And this should give us more money because we're getting the interest more often. And it does, a little over $9,000. Next we'll do monthly. Everything about this equation stays the same except for this number right here, how many times a year we're getting the interest. And this is monthly, so that's going to be 12 times. So going back to my formula, now I just need to change this to a 12 and this guy to a 12. And we should get decidedly more money because we're getting the interest 12 times a year instead of just 4. So I ended up with $9,096.98. I would definitely, if I were you, start plugging these in to make sure that you are practicing entering them correctly. The number one problem kids have is being able to put all this stuff into their calculator in the right way. So exact same problem one more time, only this time with the 365 days. We're doing this daily, so that means I'm going to get the interest every single day. So it should be not considerably more, but it should definitely be more money than any of the other options. And it does. It's $9,110.14. But there's got to be something faster than daily. There's got to be something where I can get even more interest than that. And that's where we talk about compounded continuously. So this formula up here, the long one that we used on the previous page, is used for any type of interest that's compounded annually, monthly, daily, quarterly, any type of yearly thing that we can talk about. As soon as it says compound continuously, now you're using this formula, which I believe you've seen before in previous classes. P is still the principal amount. Still how much you start with. This is your initial. E is a button on your calculator, and E is a number. And most times the button is right here. It's attached to your LN button, so it's that blue kind of sub in the background. And E is a number. It is 2.718, and it kind of keeps on repeating. So it's not a number you need to memorize, but it's kind of what I need you to know is that it's like pi. This is not a variable you're going to be solving for. It's an actual number. You've got R, which is still the rate, needs to be as a decimal, not a percent, and then T is time, just like we did in the last problem. So an investment of $5,000 is made, exact same problem, same money. So we're going to have $5,000 times e to the, and now you're going to put your 0.06 times your time, which is 10. So there's no quarterly, monthly, annually, anything like that. And then when you go to type this in, it's going to be 5,000. E to the, and again, if yours just gives you the caret, you need to put parentheses around this exponent, 0.06 times 10. So this should give us the best money because I'm getting the interest compounded continually. And granted, it's not that much more, $9,110.59, but it is more than this guy. So this was daily, getting the interest daily. This is something called compounded continuously. That's the word you want to look for. So just an introduction to exponential functions, did a little graphing with them, and then a lot of the questions are about money and using the two money formulas.